Okay, so a couple announcements before we get into it. Wait, is my mic on? Hello, hello, it's on. So obviously it was a midterm 2 days ago. You pretty much all got it back yesterday. Boy, I didn't think there would be many people showing up here the day after the exam. So I think it's time for a pop quiz. Okay, so do you have a spare piece of paper?
Yeah.
Okay, this is a pop quiz. It is, what is your username? So please don't cheat. Please don't copy off of anybody else. You can use your book if you want. We'll have one page go in each section. Just list your name and your answer to said pop quiz. Can you pass one down? So we'll pass it back and forth among the aisles and then move it eventually towards the back. Do you have a spare piece of paper? Do you have a piece of paper? Okay. So I'm not sure exactly how this will count or if it'll count at all, but I figure I should reward the people who actually are showing up today. Make it count. This will be, everyone who gets it will get an A, everyone else gets an F. I'm kidding. That's a joke for the record. I wasn't actually serious. Okay, so the, trying to be serious here. So the exam, the average was an 85. We were able to get it back in time. We don't quite have the grading guidelines or the solutions all prepared for you yet. I'm actually going to spend some time talking about that on Monday. In particular, so we will post online grading guidelines, which is exactly how to go about, how we went about grading the exam. Some of it looks arbitrary. It's not quite as arbitrary as it probably looks. And then what we'll do is talk about how to go about regrades. All that's on Monday because we were up very late last night getting the grades out, as you saw from my email right before midnight. So I'm a bit behind with some of the other grades, mostly because I've been trying to, I want to make sure the exam grades came out. Note now that, and I mentioned this in the email, when you view your grades online, it will now give you your weighted course average. And that weighted course average will be the same, will be updated every time you view it. So when a new assignment comes back, you can log on to that page, and it'll tell you your new updated weighted course average. The grades are what we talked about in the beginning of the semester on the syllabus, where a 90 and above is an A, an 80 above is a B, 70 above is a C. We don't know these sort of A plus, A minus ranges, but we'll get that figured out probably towards the very end of the semester. So, fourth homework is out. I'm going to spend some time talking about it very shortly. The fifth homework will be out next week. Obviously, the week after is spring break, and I'm not going to make you turn something in during spring break. So that will be due the week after spring break. Same thing, Friday, 10 a.m., blah, blah, blah. There is lab next week. If you are traveling early for spring break, that's fine. You really got to let us know ahead of time. Because if you miss lab and email us afterwards that you were traveling for spring break, I'm not going to be very forgiving of that. So if you are traveling, that's fine. We can rearrange you, find a different time for your lab. I'm pretty flexible. Just email cs101 at, cs@virginia.edu ahead of time. How many people think they'll actually show up to lecture next Friday, honestly? Yeah. See, that's what I'm wondering. See, being as it was a kind of small lecture today. So I might cancel lecture or not. Well, if I do have lecture, I'm sure that'll be in attendance day too. Okay. So I want to spend a bit of time talking about homework 4. Homework 4 is an if-else-if homework. And what you're going to be given is a flow chart. A flow chart. Come on. There we go. And the original flow chart that we start with is this one. Is that readable in the back? No. All right. So we want to set it to, I don't know, that? Sure. Wow. So this is the original flow chart that we started working with. I'll let you ponder this for a minute, and then I'll ramble on about it. So the idea of this is to take a flowchart and have you implement it in a Java program. So basically what will happen is it'll go through and it'll ask you various questions, and you'll answer yes or no, and eventually tell you the particular outcome. The outcomes are the purple boxes over all the way on the right. So we were afraid that this flowchart might be slightly offensive to somebody somewhere. So we're actually modifying a bit, partly for that. I don't want to go on record as saying, oh, you're a politician, all right, if you'll sell your parental units into slavery. So we've actually modified the flowchart quite a bit. It's not, oh, stop it. It's not that bad of a modification. That's terrible. I want to keep my job. I mean, so it's sort of the same stuff. Instead of a politician, I think we make fun of like CS professors, et cetera, et cetera. Are you booing me? You're booing me because I want to give thanks. So it's actually, but in all seriousness, the original flowchart would have been way too hard to implement with what you've learned in if then else. And while you might be booing me now, my goodness, would you be cursing me after you tried implementing the original flowchart? This is going to be actually much easier to implement in terms of the if-else if structure that we want you to do. Right, and this is sort of the bottom of it. So there actually are somewhat more serious applications of why we'd actually want to do this flowchart. In particular, you could have what's called an expert system, which says, okay, you have a headache. Well, did you hit your head on the wall recently? Or, do you have a hole in your head? Or, do you have a cold? And basically asks you a bunch of questions and eventually tells you the outcome. So you can do like medical diagnosis for this, for example. Or why are you dizzy? Why, et cetera, et cetera. So we just chose to do something a bit more humorous. In particular, so a couple things I do want to mention, blah, 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 blah. So we are providing you with a yes-no extractor class. All the yes-no extractor class does is it will prompt you for a question, for a yes-no answer. Turns out you can actually hit Q and it will just exit the program. But basically it prompts you for a yes-no answer. You'll notice in the flowchart we've modified, everything is ultimately a yes-no answer. And I think we provide an example about how to use it. But essentially you create a new yes-no extractor object, yes-no extractor something equals new yes-no extractor. And then you just start calling the ask user method. And you'll notice that it requires taking in a string. That string is a particular question that it needs to ask. And I'm going to show you, you actually don't have to type in all those questions, as I'll show you in a minute. It'll then return true if the user entered yes, false if the user entered no. I think it's intelligent enough to take in Y or yes or all capitals yes or stuff like that. And that's essentially how you'll be asking all those questions. So we then provide you a skeleton code. And in particular, the skeleton code has a whole bunch of strings that are the questions and answers. So this way you don't actually have to type them in. You can just call yes-no extractor with, Q human, which stands for, the question of are you human? And this is sort of the if-else-if structure to get you started. In particular, you'll notice that that is what goes in the Boolean condition of the if. If extractor dot, so of course we declare our new yes-no extractor here. And then we just do extractor dot ask user q underscore human. That's going to ask whoever's sitting in front of the computer, are you human? Oh, severe weather alert. It's going to ask the user if they're human and will either return true or false. So if the user enters that they are human, it does that block. Otherwise, it does that block. So that's the basic structure of this program. And then we go on and talk more about good programming practices and, the flow charts. Any questions on this? Okay. Yes?
This looks a lot like if else. Is there any difference, or is it
This is if-else ifs. I mean, yeah, the idea of this is that it will be if-else ifs. Because you're going to go through and say, if, you're not human, like, ask if you're human. So if human, else, meaning they're not human, are you, I don't know, a professor? Else, if you're not, are you a chimpanzee? Else, if, or, whatever it goes through. So it's going to be a series of if-else ifs. You're going to have some if-else ifs nested within other if-else ifs. But right, it will not work if you try a switch. You can try it all you want. You're going to be wasting your time. You will not be able to implement this particular assignment the way it's stated as a switch. Other questions, comments, concerns? Okay. Hit that button and that button. Nope, got that. We got that. Okay. I was thinking about going over the exam today. I think I'll actually spend some time. Well, Word's not decided to crash, so I guess that works out well. I actually was going to spend some time going over that on Monday, because at that point I'll have the grading guidelines all ready, so I think it'll be a bit more informative. In general, we mentioned that all regrades need to be turned in within 10 days. That 10 days will obviously start next Monday. And I'm not going to count spring break. So you'll have until probably the end of the week after spring break to hand in any regrades for this. Oh, there we go. Right. Okay. So we're now going to start moving into Chapter 4, which is iteration. We've seen decisions, if else, if, and switch. And notice that each of those will control whether or not some part of the Java program, whether it's one statement, a series of statements, maybe in a block, whatever, is executed. It can either be executed 0 times or 1 time. In a switch statement, most of the cases will be executed 0 times, but maybe there's one switch statement that's executed once, or however you have it. So essentially a decision, meaning an if else, if, or switch, controls whether or not it's executed 0 times or 1 time. But there are a lot of times that we want things to be executed more than once. Enter 10 integers. Read 100 websites, or something along those lines. And this is what we get into iteration, or looping. And it turns out that Java actually provides, 3 different looping structures. All of them are actually the same. In fact, anything you do with one can be exactly translated into any of the others. But as we're going to see, they're somewhat easier. Sometimes it's easier to do one versus the other in terms of how humans think the program should run. As far as the computer is concerned, they're all pretty much the same thing. So let's start with our first example of averaging values. What we want to do is we want to take in some list of numbers from the keyboard, add them up, and average them. The problem is we don't know a priori, meaning we don't know ahead of time how many numbers they're going to enter. If we knew for a fact that they were going to enter 4 integers, we could say, 1, 2, 3, 4, great, we're done. But maybe they're going to enter 1,000, maybe 10, maybe 1. So that is the problem that we're actually going to need loops for, because we don't know ahead of time how many values they're going to enter. Numbers of 1 per line. We are only dealing with positive numbers here, because that makes this program work out a lot easier. Obviously, there are ways to avoid that. But anytime the user enters a negative number, that's telling the program that we don't want to average any more numbers. So maybe I'm averaging your test scores, and so far nobody got a negative score on the test. So I enter all the positive numbers, possibly 0, although nobody did get a 0. And actually, one semester someone did get a 0 on a test. It was actually pretty impressive to get absolutely no credit on any question on the entire exam. But I'm sorry, I digress. So negative numbers telling the program, I'm done entering values. So, and the things that I want to point out, of course, is that we don't know ahead of time how many values we're going to enter. Maybe it's the people in this room, which is, I don't know, maybe 100. Maybe it's all the people registered in the course. Maybe it's all the people just in 101E. So this is the algorithm. Prepare for processing, create your scanner, do your legends, get the first input. Read in the first number that the user is going to start averaging. while there is more numbers to be read in. And notice that that is in bright yellow because this is the relevant portion that deals with iterations. So while there are more numbers to be read in, we're going to read in another line and sort of process it so far. We're going to keep a running sum and sort of a running total of this. So this part here, okay, what color? Black. So this part here is going to be repeated as many times as necessary. It's going to be repeated while there is input left, meaning while there are more numbers to be read in. Perform final processing, which is, compute the average and print it out. So, what slide am I on here? Right. That's the stuff from 2 slides ago. A sample run, and this is the run we're going to study. We enter our directions, enter positive numbers, 1 per line, indicate the end of line with a negative number. And we enter our, in this case, 3 values, because it's kind of hard to trace it if you get into 1,000. But right now we're going to enter 3 values. That adds up to 6.3, and the average is going to be a 2.1, I think. Did I get that right? Probably. -1 is telling the program that I don't have any more input to enter. I am finished. And it'll tell you the average is 2.1. So this is the skeleton or the outline of the code. A lot of this is the various steps that we saw here with the while loop actually highlighted in yellow. So set up the input. That's going to be creating the scanner. Prompt the user for the first value. Enter your values 1 per line. Read the first value, meaning the first number to be averaged, 4.5 in this example, is actually read there outside the while loop. Within the while loop, we're going to read the remaining 3 values, meaning we're going to read in the 0.5, the 1.3, and then the -1. And this loop is going to keep executing while the value read in is greater than or equal to 0. So value is going to be a double variable that holds the most recently entered value. And while that number is not negative, meaning 0 positive, we're going to keep looping around. So this is what we mean when we say that a negative number acts as a sentinel. It basically, once we enter a negative number, it's telling the program not to continue. So the while loop is kind of like a for loop. It's a for loop. Sorry, you haven't seen that. It's kind of like an if statement. You have the keyword while, just like if. You have a Boolean condition inside parentheses, and you have optional curly braces if it's more than one statement. And what the while loop will do is it will keep executing the body while the condition is true. An if statement will execute it once if the condition is true. While loop will keep executing it while the condition is true. The condition is true for 15 iterations of the loop, or 15 times, then that loop will be executed 15 times. If it's initially false, the loop is not executed. Meaning if the first value enter is -17, then it will not bother executing that loop. So it looks at this condition, says, is it true? If so, I'm going to execute everything in the loop. And then it checks the condition again. Is it true? If so, execute everything inside the loop. When we're all done, we're going to compute the final average and print it out. Any questions about this pseudocode other than the minor details about how the while loop work? Yes?
Not to detract from your lecture on averages, but isn't there a quicker way of doing it through the math class?
The question is there a quicker way to do it through the math class? As far as I'm aware, I don't think the math class has an average method. It might, but realize that a lot of the examples that I first am going over are somewhat easier examples to show you how it works. Would I actually write this long of code to average a couple values? Probably not. And indeed, in a week, you probably wouldn't write, code like this. But I think it serves as a good example just to start off with. So here we have the program. I hope you can read it in the back. Here we have the program with everything sort of filled out. In particular, we're going to have two variables up here, values processed and values sum. What happens is that if the user has entered 27 values, values processed is going to be equal to 27, in that so many values have so far been read in. And value sum is going to be the sum of all of those values together. And at the very end, we're going to divide the sum of the values by however many we've read in, and that's how we compute our average. So we don't have to remember each number from one iteration to the next, because every time we read in a number, we add that number to value sum, and then we increment the number of values processed. So let's say we create our scanner, we tell the user to enter input, we read in the first value into the double variable aptly called value. It checks that condition. If that condition is true, it's going to execute the body of the loop. So let's assume for now that the first value entered is indeed non-negative. It adds it to value sum, it increments value processed, and reads in the next value. Because we're in a while loop, it's going to go through and execute the entire body all over again if this condition is true. So it's going to keep doing that until we enter a negative value. Once it's all done, assuming that we've entered values, it computes the average and prints it out. So obviously that was a lot to throw at you on one slide. Right. Just so you don't think I'm making this up. Number games? No. Okay, maybe you will think I'm making it up because I can't seem to find it. Oh, there we go. So we enter a couple numbers here, 77, 777, 8, 90. Not really. So I entered 777, 8, and 90, which I'm sure are all valid scores on the exam. I entered -1, and it tells me the average is about 292. Actually, one time there was a mistake, not this semester, and someone got 100 on a lab quiz out of 4, and their average was like 130 after that. Okay, so in a moment or two, I'm going to go over in great detail how that program works. It's generic stuff about while. We have an expression and we have an action, just like an if. It's the same basic format. The thing is that it's going to test that expression periodically, meaning every iteration of the loop, and while that expression is true, it's going to execute the body, or action. Action can either be a single statement or one or more statements enclosed by curly braces. Again, we recommend, use the curly braces. So this is the body of the loop. Right. Okay, we'll go to the previous slide. We have our really fun flowcharts because, my goodness, do we love flowcharts. It tests the expression. If it's true, it executes action and goes back around to test the expression. If it's false, we take this detour and keep on going. Actually, flowcharts aren't so bad. It's just there's some people who use flowcharts and think they're the greatest thing, and I kind of get fed up with that. Anyway, so here we have the program, and I'm actually going to go through a trace of how it works. We're going to assume, for sake of argument, that the person who typed these values in entered the same values that were entered in on the previous slide: 4.5, 0.5, 1.3, and -1. So int values processed is 0. We have that double variable. Wait, try that again. Int values processed equals 0 creates, yes, an int variable. Value sum is 0. That's double. This line is going to read in the very first value. So it's going to read in the 4.5 because that's the very first value that's entered by the keyboard. So the yellow is the value that was just read in. It checks now to see if that value is greater than or equal to 0. Well, 4.5 is greater than or equal to 0, so we're going to execute the body. We add 4.5 to value sum. Value sum is going to become 4.5. We increment values processed, and then we read in the next value, which is now 0.5. So the blue is the stuff that's used up. The yellow is the stuff that's currently being read. it goes back around to the top of the loop and checks that condition again. Indeed, 0.5 is greater than or equal to 0, so we're going to go through it again. Add 0.5 to value sum, that's going to become 5.0. Increment values processed, so that's going to become 2. And then read in the next value, which is the 1.3. So again, it goes around to the top, checks that condition. That condition is still true. 1.3 is greater than or equal to 0. So add 1.3 to 5.0, we're going to get 6.3. Increment values processed to 3. Read in the next value. At that point, we've read in -1. It goes back around to the top of the loop and says, look, value, it's not the case that value is greater than or equal to 0, or value greater than or equal to 0 evaluates to false. So the while loop ends. And we start executing the line immediately after it. If values processed are greater than 0, well, it is. We process 3 values. We're going to compute the average, which divides that by that, and we print it out. How many people felt they understood this program? Oh, good. I'm seeing a good number of hands. Okay. Wait. Question? Okay. So what do these pictures mean? Yes, something that I'm sure none of you do before you're 21.
Royal blue.
Close.
Royal coat?
Lions is the second part. Dandelions. A salted peanut. Eggplant. Dr. Pepper. Pool table. Tap dancers. Card shark. I like the poker chips that he's going after. I'll give you a hint, Michael Jackson. King of Pop. I'm not saying I agree with it. It's just, well, he's the one who sent the fax to MTV in like 1989 saying, you will now refer to Michael Jackson as the King of Pop always. And MTV's like, pfft. That was when MTV actually played music. iPod. Gatorade. Nightmare. Whole milk. And this is what you can do if you have lots of free time in Photoshop or GIMP. Okay, so I want to go through a couple more examples. I know, because I go from that to like converting text to lowercase. Well, we have to go through the converting text to lowercase. A lot of this chapter is going to be going through a number of examples. And the next example is, not surprisingly, converting text to lowercase. So here we have a main method in some class somewhere that's going to read in a number of lines and convert them all to lowercase characters. So any capitals you have, obviously the capital is removed and it's converted to lowercase. Where am I going with this? Give me 1 second. All right. So we're going to go over the details of this program in a moment or two. But this is how you might actually enter it, where you're writing it. Now, granted, this is black on white instead of white on black, which is what you're used to, but bear with me. So you enter a bunch of stuff, and you notice that all the nice capital W's are lowercase, and magically it works. So again, we need to tell the user, or we need the user to be able to tell the computer how to, when it's actually finished entering input. Previously we did, and here we're going to read in strings, right? We're going to read in 1 string, 2, 3 strings, 3 strings. And when we're reading in numbers, we could just say a negative number told the program that the user doesn't want to enter any more input. Here, we can't do that, just because we're not entering numbers. So we're going to enter a Control-Z. For those of you who are using Linux or Unix, it's a Control-D, as in Delta. But for DOS, Windows, and variants, it's a Control-Z, as in Zulu. I'm not quite sure what it is for Mac. Just try a couple and something will work. Anyway, that Control-Z is a very special, has a very special meaning, which we'll get to in a minute or two, that tells the program you're all finished entering input, and then it'll go and spit back your conversion. I'm not going to actually run it, but you can take my word. It actually works. So we create our scanner. We tell it to use it to enter some input, and then, very poorly indented, we create a converted string. This converted string is going to hold the lowercase text. So as we enter line by line, converted is going to hold all of the lines that have already been converted into lowercase. So while standard in.hasNext, I've mentioned the hasNext method briefly, but we haven't talked about it in great detail. The hasNext essentially is going to return true while there is more input to be read in. If you were reading from a file, and we're going to see in a couple slides, we'll probably get to it Monday, how to read from a file, then once you reach the end of the file, there's no more input. hasNext is going to return false. When you are reading from a keyboard, if the user enters Control-Z, then that's how Java knows that hasNext should start returning false. So Control-Z, which I mentioned on a couple slides ago, that's the special command that tells the scanner there is no more input to be read in. So hasNext returns false at that point. So basically it's saying, while the user has not entered Control-Z, I'm going to do all that stuff there. So current line, that's going to read in the next line from the keyboard. This is going to convert it to lowercase. There's 1,000 methods, well, not 1,000. There's hundreds of methods in the string class. One of them is to lowercase. Not surprisingly, it converts the string to lowercase, right? So current conversion is then that line that was read in lowercase. We then add that line to converted. And this line of code here is fairly complex, as it turns out. I think we're on purple today. So here we have the append operator, or plus equals. That's saying converted is going to equal converted plus whatever else. So you're going to add on to the end of the converted string. And what it's going to add on is current conversion, which is the lowercase from the previous line, and a return. So that's basically saying that it's this way each line that's read in the converted string will be on a separate line as well. As it turns out, okay, I'm going to use black. Ready? We don't actually need these parentheses. And that works just as well also. So that's just going to take, it's going to add to converted, whatever is read in, and then a return so that everything is nicely on separate lines. It then loops around. I need a quick way to encode it. It then loops around and will keep reading in lines while the user has not entered Control-Z. Once the user does enter Control-Z, that's false, and we go and we print out the line over at the bottom there. How many people feel they understand this code? Okay, I'm seeing most hands. Right, this was that line that I was telling you about. Whoops. Guess what's coming up next? This is the line I was telling you about. The plus equals is the append operator. It works for ints. X plus equals 5 is going to take whatever value of x is, add 5 to it, and that's going to be the new value of x. When we're dealing with strings, it's going to add whatever on the right onto converted. So converted equals converted plus the parenthetical there. Current conversion is the string that we just converted to lowercase on the previous in the code on the previous slide, and that's just the return, or the new line is going to allow each line in the converted to be, displayed separately as opposed to one really long line. It's not animated. Okay, having given you a headache with this slide, so I want to move into, we're going to talk a bit more about loop design and also how to read from a file. Turns out that the scanner class that we've seen and used and all know and love can actually read from a file quite effectively as well. So when we're actually dealing with loops, there's a number of things that need to be considered. In particular, when a loop is about to start, there's a Boolean condition, and something needs to set that Boolean condition or get that Boolean condition ready. For example, in the one where we average the values, we said while value is greater than or equal to 0. Well, that means that value had to have a value read into it. Right before that, we said value equals standard in dot next in. So when we talk about initialization, that means what things you have to prepare for in order to have the loop condition work properly. For the loop processing, there's a lot of things that need to be done so that the loop each iteration of the loop can go through and work properly. For example, in the lowercase conversion that we just saw, there was the converted the converted string object. We had to create the string object that we were going to keep adding text to as we went through it. This is a big problem. We're going to be focusing on this later, is how do you know if the loop terminates? Everybody at some point will write a loop that just goes on forever. It just circles around because you screw up your condition, and it loops forever and ever, and you basically have to close the DOS window in order to get it to stop. You need to make sure when you're doing your loops that you know when it's supposed to terminate, and that you tell the computer appropriately when to terminate. Meaning, if you have an incorrect termination condition, I didn't like the way I explained that. If you have a Boolean condition that is never false, so for whatever reason, your Boolean condition is never ever false, then it's never going to terminate. It's always going to loop around. So you need to be sure that the computer or the program somehow will eventually end the loop. Obviously, what the loop should do. A lot of times the loop will do stuff getting ready for the next iteration of the loop. When you ready in the integers or doubles to be averaged, the last line of the loop read in the next value so that the loop can go around again, et cetera, et cetera. So these are some things that as we start playing around with loops a bit more, we're going to see how they come into play. So we've created scanners that read from the keyboard. And I believe there was a lab so far that a lab created a scanner that read from a file, correct? How many people have seen that? Am I totally smoking crack here? I guess so. At some point very soon then, I know it's in a lab. I forgot if it was in a lab that you saw already, or maybe it's the lab that you're going to see this week. It's sunny and 44 degrees. There is a lab that will talk about how to actually read stuff in from a file. In particular, here we're creating a new scanner object. And this is the difference. Instead of saying system.in, you say new file, file name. File name is some string that represents the particular name of the file on the disk. File is a class that's in the java.io library, at which point we have to have somewhere import java.io. Yeah. Sorry, java.io, sorry. Question?
Okay. So like if the actual file in our, I don't know, in our folder was called poem.txt, then do we type in poem.txt or do we just type in poem?
The question was, if you have, so file name is the string, and if you have a file sitting in a directory, do you need the extension? You do. So if it's, because you could have poem.txt, poem.doc, poem.mp3, so you need to have the file name be the exact name of the file. So there's a number of things that this is actually a surprisingly powerful concept. So this is the same scanner class that we've seen and that we've used. Granted, we're using a different file, a file class here. It's in java.io, so we have to have import java.io.star. But the thing that is really powerful about this is once we create our scanner, whether it's reads in from a file or reads in from the keyboard, it's exactly the same thing to use it. It's the same methods. It's the same next int, next double, next line, has next. The exact same methods, the exact same thing of reading it in, whether, and as far as Java is concerned, or as far as our programs are concerned, after it's created, it's the exact same way of using it, whether or not it's reading it in from the keyboard or reading it in from a file. And this ends up being fairly powerful because we don't have to learn a whole new set of commands and methods and procedures for going about doing it. We already know how to use a scanner. All we need to do is this one line. So there's the class file. I'm sorry, question?
Does the file that you're importing have to be in the same directory as the Java?
The question is, that's a good question. The question is, does the file that you are reading in have to be in the same directory? It does not, but if it's in a different directory, you have to tell it which directory it's in. And that then becomes a problem because the way DOS tells directories, so let's say you had this string. That's a parent directory. DOS likes to use the backslash to tell directories. And you have that as, that's basically saying, go up one directory and look for the new file.txt. Who sees a problem with this? \n. So when you actually do this, if I was to do, look at this, Java looks at this and says, oh, you mean \n. So it's going to see that ... return new file.txt. So it's going to look in the current directory for a ... return new file.txt. And that creates a bit of a hassle. So then you have to say ... new file.txt. That's how you, for example, would say a parent directory or a subdirectory, is you need to use a / so that you don't start getting it confused with a \n or \t or something like that. What we are going to do in this course, in next lab or the next lab or two, it's always going to be in the same directory. So you're not going to have to worry about going into different directories. So we have class file. It's lives in the java.io library and allows us to access files. We're only going to see this in terms of the scanner class, but there are other ways to access files as well. The particular constructor, meaning how you create a file object, just takes in the string file name that you want that file to use. Right. Blah, 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 blah. Stuff that we've seen. So here we have the text that will actually read in from a file. So the first line is stuff that we've seen already. Create a scanner that reads in from the keyboard. Scanner standard in for the standard input. We then tell the user to enter the file name, and we read it into the string called file name. So there the user is specifying what file name she wants to read in. Notice here we create a second scanner. This scanner is now reading in from the specified file. So we now have two scanner objects in memory. One called standard in is reading in from the keyboard, and the other called file in is reading in from the file. And then this here is essentially going to work pretty much like the previous ones. we read in things with the next line. We basically read in with the next line method. So this says, read in the next line while it's not null, meaning while there was a line in the file to read in, print it out, and then read in the next line. So once we've created the scanner, whether it's a standard in scanner or a file in scanner, it actually operates the exact same way. We just call the next line method, and it reads from a file the next line in the file. From the keyboard, it waits for the user to enter the next line and reads that in. And it says, while current line is not equal to null. If you're reading in from a file, once you hit the end of the file, because files generally are all finite in size, once you hit the end of the file, any additional call to next line, will return null. So that's why it says, well, current line is not equal to null. Because once you've hit the end of the file, it is null, and then that will evaluate to false. So this is a quick overview as to how to read in a file. As I said, you're going to be looking at this in Lab 2 in, I think, very shortly. Okay. Right, and this is just the various things that I talked about. So, before you go, I want to properly demotivate you for the weekend. Limitations. Until you spread your wings, you'll have no idea how far you can walk. So you know that the mascot for Linux is a penguin because a penguin bit the guy who created Linux? Leaders. Leaders are like eagles. We don't have either of them here. Losing. At first you don't succeed. Failure may be your style. Flattery. If you want to get to the top, prepare to kiss a lot of the bottom. I will not put that up on my office. Don't even try. Have a great weekend.